Okay, so to start, we're given an equation that models what? What does this equation represent?
Height.
This equation models the height of a rocket after a certain number of seconds. So we're going to use this equation to see, if we know the time, okay, t represents time, we can figure out how high, what is the height of the rocket, okay? Okay, so the question asks us, when will her rocket reach a height of 60 meters? So if we want to know when it reaches that height, we need to figure out which variable? T. We want to know how long it takes, the length of time it takes for her rocket to reach a height of 60. So we're given the height. If you're given the value of h, what would you do with that information? Plug it into the equation. So that's the first step. When h is equal to 60, okay, we're replacing height with 60. We need to figure out what is t equal to. What is the time? How long does it take her rocket to get to 60 meters? We need to figure out what t is equal to. Okay, so now that we've made h 60, let's rearrange this equation to put it in standard form. Okay, so how would I do that? Standard form is equal to, it's ax squared plus bx plus c equals 0. That's standard form, right? Is equal to 0. I can write an equation and set it equal to 0. Doesn't change anything. So what would be my ax squared in the equation? Okay, so we're going to write negative 5t squared. What would be my bx? Plus 40t. And now we want to get rid of the plus 60. It's on the left side. So what is it going to become? What is c? Minus 60. Good. Is equal to 0. Okay, now it's in standard form. When h is 60, we need to figure out t. So we have our equation here. And we need to solve for t. If you were to graph this, okay, we're going to look at the graph after, would time or height be on the x-axis? Time would be on the x-axis, and height would be the y-axis. So we're trying to find out what t is equal to when h is 60, right? So we're going to factor this to figure out the value of t. Are we going to have two values of t, do you think?
Yes.
So factoring strategies, first thing we look at is to see if there's a greatest common factor. Is there a greatest common factor? Okay, what is the greatest common factor? Negative 5, good. So we're going to divide everything by negative 5. How do you know that t is not a common factor? Because 60 doesn't have a t with it. Good. Okay, so factored form is going to be negative 5 bracket. What am I left with? T squared. Positive divided by a negative is negative. 40 divided by 5. 8. T, bless you. Negative divided by a negative. Positive. 60 divided by 5. 12. Equal to 0. Can we factor this more? Can this be factored more? Yes.
Yes.
Product sum. We're looking for two things that multiply together to give us what?
12.
Positive 12 and adds up to negative 8. We know that it has to be negative times a negative because when you add them it has to equal a negative. So you guys came up with it. Negative 6 and negative 2. When you add those together we get negative 8. So how do I write this in fully factored form now? T minus 6, oops, t minus 2. So what is t equal to?
6.
T minus 6 is equal to 0, so t equals positive 6. And t minus 2 is equal to 0, so t is also equal to positive 2. Okay, so what that means is that the rocket is 60 meters above the ground at 2 seconds and again at 6 seconds. Think about a rocket. It goes up and then it has to come down, right? Okay, it's important to note, just like I said, that our values of t were 2 and 6. Those are not the x-intercepts. Those were the points when y was 60. So those represented a coordinate. Okay, so when x was 2 After 2 seconds, the rocket reached 60 meters, and then it still went up higher, okay, and I just highlighted the vertex here. We can calculate the vertex, right? We could have found the axis of symmetry, and we could have used, we can use t equals 2 and t equals 6 to find the axis of symmetry. Even though those aren't the x-intercepts, remember with partial factoring, you're finding two values of y that are the same because we know that regardless, the axis of symmetry is still halfway between those 2 points, right? And is it halfway, is 4 halfway between 0 and 8? Okay, so the x-intercepts are 0 and 8. So what does that mean in this context? If the first x-intercept's 0 and the second one is 8, what does that mean about the rocket? What can you tell me? How long was this rocket launched for? So it took 8 seconds until the rocket went back down to the ground, right? So the rocket went up. The highest point it reached was what? How many meters? 80 meters. It came back down. When it was in the air for 6 seconds, it was at the height of 60 meters again because it comes back down. And then at 8 seconds, it hit the ground after 8 seconds.